Today's topic is numerical solution of ordinary differential equations. The ordinary differential equations of the form dy by dx equal to f of xy. Here dy by dx has an order 1. A second order derivative will be d square y by dx square. Third order derivative will be d cube y by dx cube. So in this topic we will be learning to solve first order linear differential equations of the form dy by dx equal to f of xy. Now there are three methods to solve first order differential equations. Three numerical solutions of ODE can be obtained by Picard's method, Taylor series method and Runge-Kutta method. Now coming to Picard's method, with the first order differential equation dy by dx equal to f of xy with initial condition y equal to y naught when x equal to x naught, we see that this equation which contains the variable y under the integral sign is called an integral equation. The first approximation is given by y1 equal to y naught plus integral x naught to x f of x y naught dx. So Picard's method is again an iterative process where we repeat the iteration, that is we repeat the same procedure again and again. We find the second approximation from the first approximation, third approximation from the second approximation and so on. So to find the second one, y2 is equal to y naught plus integral x naught to x f of x y1 dx. Similarly, third approximation is obtained from y2. y3 equal to y naught plus integral x naught to x f of x y2 dx. Each of the y1 will be a function of x. Proceeding, we get y1, y2, y3, etc. each giving a better approximation than the previous one. So this is Picard's method. Now let's see how to solve problems using Picard's method of successive approximations. Using this method, let us find the solution of dy by dx equal to 1 plus xy subjected to y equal to 0 when x equal to 0 up to third approximation, and then find y when x is equal to 0.2. Now given dy by dx equal to 1 plus xy, the right hand side is f of xy function, that is equal to 1 plus xy. Initial conditions are given to be x naught equal to 0, y naught equal to 0. So y is equal to y naught plus integral x naught to x f of xy dx. Y naught is 0, substitute, plus integral x naught is 0. So integral 0 to x 1 plus xy dx. So that is the first equation. So that we can find y1 from y naught, that is the first approximation can be found from the initial approximation. So y1 is equal to y naught plus integral x naught to x f of x y naught dx. Y naught is 0, x naught is 0. F of x y naught is 1 plus x y naught is 0. So 1 plus x into 0 will give us 1. Integral 1 dx is x. And limits from 0 to x. When we substitute the limits, we will get x. So we can see here that y1 is a function of x. Similarly, y2, y3 will also be functions of x. So from y1 we can find y2. y2 is equal to y naught plus integral x naught to x f of x y1 dx. Y naught is 0 and x naught is 0. So we will get integral 0 to x 1 plus x y1 dx. But y1 is 1. Therefore, we will get integral 0 to x 1 plus x square dx. Integration of 1 is x, integration of x square is x cube by 3, limits from 0 to x will give us x plus x cube by 3. Next, y3 to be found from y2, that is y naught plus integral x naught to x 1 plus x y2 dx. Y naught is 0, x naught is 0, and y2 is x plus x cubed by 3. Therefore, integral 0 to x 1 plus x into y2 which is obtained in the previous step. So, x plus x cubed by 3 into x plus 1 is under the integral with respect to dx. Removing the brackets, we would get 1 plus x square plus x power 4 by 3. Integration of 1 is x. Integration of x square is x cubed by 3. Integration of x power 4 by 3 is x power 5 by 5 into 3. 5 into 3 will give us 15. Now we are asked to solve this problem up to third approximation. Hence we stop with y3. But further we are asked to find y when x is equal to 0.2. Therefore, keeping y3 as a desired solution, we are proceeding to evaluate y at x equal to 0.2. Hence in y3, which is x plus x cubed by 3 plus x power 5 by 15, substitute for x equal to 0.2. That will give us 0.2 plus 0.2 cubed by 3 plus 0.2 power 5 by 15. And calculating, y will be equal to 0.202687. Now let us see another problem. In the same way, using Picard's method, we can find y when x is equal to 0.2, given that y is equal to 1 when x equal to 0 for the function dy by dx equal to x plus y. So given that, when it says given that and the values of x and y, those values are the initial values. That is x naught equal to 0, y naught equal to 0. And right hand side function is x plus y. Therefore, f of xy is equal to x plus y and y is equal to Picard's formula y naught plus integral x naught to x f of xy dx, that is equal to 1 plus integral 0 to x plus y dx. 1 because y naught is 1 and x naught is 0. Further, 1 plus integral 0 to x. To find y1, we use y naught, x plus y naught is 1. So substituting 1 in place of y naught, we will get 1 plus integral 0 to x plus 1 dx. Integration of x is x squared by 2, integration of 1 is x. That will lead us to y1 equal to 1 plus x squared by 2 plus x. Next, to find second approximation, y2 is equal to y naught plus integral x naught to x f of x y1 dx. y naught is 1, x naught is 0 into f of x y1. f of xy is x plus y. So f of x y1 will be x plus y1. That will give us 1 plus integral 0 to x plus y1 dx. But y1 is found in the previous step. That is y1 is 1 plus x squared by 2 plus x. So substituting in place of y1, we will get y2 equal to 1 plus integral 0 to x plus 1 plus x squared by 2. But x plus x is 2x. So further integrating, integration of 1 is x. So we will get 1 plus integration of 1 is x. Integration of 2x is 2x squared by 2. That will give us x square, plus integration of x square by 2 is x cubed by 3 into this number which is already there into 3. That will give us x cubed by 6. This is y3, which is to be found in the next step. That was 1 plus integral 0 to x plus y2 dx. Substituting for y2 and integrating, we will get y3 equation. That is 1 plus x square plus x cubed by 3 plus x power 4 by 24. So this is y3. By default, we have to find at least up to third approximation. Having found this, initially we are asked to find y when x is equal to 0.2. So in y3, substitute for x as 0.1. So we have to find y equal to 1 plus x square plus x cubed by 3 plus x power 4 by 24. In place of x, substitute 0.1 and evaluate. By evaluating, we will get y equal to 1.1103371. Thank you.